In this video, we present SCFusion. Despite the progress in scene reconstruction, the reconstructed scene inevitably suffers from occlusions. There are methods that have been proposed to tackle this issue. However, most of them treat this task as a post-optimization process, which makes them unable to be used on real-time applications. We propose a method that enables semantic scene completion to be used in reconstruction time. There are three main difficulties that hinder the possibility to bring the existing methods to real time. First, the inconsistent input and output format of the networks. The existing methods often take signed input and predict unsigned output. This introduces ambiguity when fusing the prediction back to the scene. Second, a fusion method is needed to handle the multiple predictions. And third, a dataset for training. A real-world dataset is missing in this research field. We generate a new dataset by replacing objects in real-world scans with CAD models. Our dataset is built on top of ScanNet, Scan2CAD, and ShapeNet. For the details of the data generation, please refer to our paper. We will now introduce our method. We propose a framework that uses occupancy mapping all over the system. The consistent format allows us to integrate the prediction more easily. Our framework consists of two pipelines. Given a pose and its corresponding depth map, the front end reconstructs the scene to a global map. Then, the back end interacts with the global map by extracting submaps, completing the submaps, and fusing them back to the global map. We use the view voxel of a camera pose to find candidate regions that may need a completion. We cover the view voxel region with submaps. A submap is defined as an axis-aligned bounding box region in the global coordinate system. Those submaps are added to a queue, which stores all the candidate regions. Each submap in the queue is then filtered by checking the percentage of the outdated voxel within that region. A voxel is considered outdated if the difference between the time step of the voxel and the system is larger than 30 steps. A submap is discarded if the percentage of the outdated voxel is below 30%. If a submap passes the criteria, we extract the local information and use them as the input of our network to predict missing information. We propose a novel network architecture that fully utilizes the information provided from occupancy mapping. The network not only takes the occupancy probability as the input, but also an unknown mask which is generated by using the explicit unknown status from the occupancy mapping. With the unknown mask, our network is able to predict geometry more precisely. And better result quantitatively. After the semantic scene completion, we fuse the predicted result back to the global map with the proposed fusion policy. We utilize occupied, empty, and unknown voxel status from occupancy mapping to fuse the predictions. We fuse the predicted occupancy only to the voxels with unknown status. For semantic prediction, we fuse them only to the occupied voxels. With the fusion policies, we are able to complete the scene while maintaining the reconstruction quality. And finally, we apply a dense conditional random field to handle the spatial discontinuity introduced by our submap method. We only store a label and a confidence value in each voxel. If the next prediction matches the current one, we accumulate the confidence value. Otherwise, we reduce the value. If the new prediction has a higher confidence, we replace the label and using the residual as the new confidence value. We have introduced every component of our framework. Now we will show the qualitative comparison of our method against a naive integration approach by using a single frame completion method, FOCnet, and an offline full-scene completion method, ScanComplete. At the end of this video, we demonstrate our framework on a sequence from ScanNet. Note that in this video, we only integrate every 200 frames to highlight the completion effect. In addition, we demonstrate our method on a self-recorded scene. Thank you for watching.